I saved the double angle identity for cosine last because it actually has multiple forms, and so I want to go through each one of those with you. First, a reminder, the sum difference identity for cosine says cosine of A plus B is cosine of A cosine B minus sine A sine B. So if I change this into cosine of 2A, or the cosine of A plus A, then I would get cosine A minus sine A sine A. So one of the forms of the double angle identity for cosine is just to say cosine squared A minus sine squared A. But now if you think about it, remember sine squared from our Pythagorean identities plus cosine squared equals 1. I could say that either sine squared is equal to 1 minus cosine squared, or cosine squared is equal to 1 minus sine squared. So if I wanted to have this identity all in terms of just one function, I could take out the cosine squared A and plug in 1 minus sine squared A. I already have a sine squared A, so that would be the same as 1 minus 2 sine squared A. Or, so this was one of them, I could replace the sine squared A with 1 minus cosine squared. So that would be cosine squared A minus, and then I said sine squared is the same as 1 minus cosine squared A. When I distribute that negative, I would end up with 2 cosine squared A minus 1. There are different times and different uses for each one of these. I was most familiar with this top one, but the next thing we'll show you is how this bottom one is going to come into play.